So now it's time to test the BOD, or biochemical oxygen demand. BOD is just a measure of how much organic matter that you have inside of a sample of water. So the way we test that is we compare the dissolved oxygen content as it first came out of the stream with dissolved oxygen content 5 days after, with no opportunity for photosynthesis. So that is why we have covered our sample bottle with aluminum foil, so there can be no light to penetrate inside and it's totally dark. And that way there's no photosynthesis that can occur to create any more oxygen. The only thing that's occurring in this bottle is decomposition of the organic matter by microorganisms, where they use up all the available oxygen inside the sample. So the sample before, the light bottle sample, which we took immediately after we took the sample, should have some oxygen content. We measure that in milligrams per liter. This one also should have an oxygen content, but it should be lower because all the oxygen in here has been used up over the past 5 days by these microorganisms decomposing all the organic matter. So what I have done is I took the water out of this bottle, and I have gone ahead and I have started to do the DO test, and I've fixed the oxygen in the sample bottle here. I don't know if you can tell, but this is probably a little bit lighter than the sample we got before, as expected. The little red flakes that you might have seen in here before were a lot easier to dissolve this time than it was previously. So this sample has already been fixed. We're ready to go and do the titration at this point. So the first thing I need to do is, let me get this stool out of the way, fill this titrating vial up to the 20 milliliter line. Okay. This sample will keep for a minute just in case something goes wrong. And I have to titrate this solution until it's a pale yellow. So right now it's a kind of golden color. It's not as golden, I don't think, as the one previously. But I'll put a few drops of this in here and try to turn it some sort of pale yellow color. It's probably a pretty arbitrary color. So it started to turn there a little bit. I'll just add a little bit more. Yeah, that's going to be, all right, we'll call that pale yellow. I don't know how much we had before, but instead of golden, maybe just a couple more drops, just to be on the safe side. There we go. That's pale yellow. We'll call that one pale yellow. Sorry if I've been over here, but I haven't really been paying attention. So we'll call that pale yellow. The next thing to do is put 8 drops of the starch indicator in here to turn this sample blue. I'm pretty sure it's 8 drops. 8 drops of starch indicator. So here's the starch indicator, and we'll just go 1, 2, 3, 4, 5, 6, 7, 8. Mix this around a little bit. Let's turn blue. And the next thing I'm going to do is titrate until that blue color disappears. So just 1 or 2 drops at a time. It's really turning. Trying to. 2 drops there. All right, 1 or 2 more drops ought to do it, I think. There's 1, 2. Let's see if that does it. 1 more. Maybe 1 last drop to turn it clear. Turns clear right there. Okay, so that's clear. I'm going to read. It's got a blue tinge to it, so I'm going to go 1 more drop just for good measure. Right there. Now it's totally clear. 100% clear. Okay, so I'm going to read the bottom of my scale here, and I look like it's about 6.2. So 6.2 milligrams per liter of oxygen. So like I said, it's lower. It's not a whole lot lower. It's not as low as I actually expected it to be, but it is. It's 6.2. Before, I'm pretty sure it was 6.8. So now you can subtract the 2 and get your dissolved oxygen. I'm sorry, get your biochemical oxygen demand, and you can read your Q curve to get the Q value, and you're done with the lab. So there you go.